Okay, hello. In this video, we're going to go through an investigation on tangent properties. So this is the start of chapter 6. I'm going to fill in these three conjectures. So here is the investigation. We have a circle with radius AB, and I've constructed a tangent line at B. So the first thing we're going to investigate is what is the angle created here? And you can probably tell, no matter what, if I kind of move this around, it looks like that the perpendicular line is, I already blew it. It looks like the tangent line is perpendicular to the radius. So in order to measure that, I just need to create another point, excuse me, and measure this angle ABC. And we can see that this angle is perpendicular no matter what. So even if I move this around, this tangent line is always perpendicular to a radius. So any radius that I make, I could make another radius here. And then if I made a tangent line at D, tangent, so I click on D and then the circle, this would also be perpendicular. Okay, and then we get a kind of a cool quadrilateral that I just made here. If I move, let's see, I make a point right there. What kind of a quadrilateral would this be? Well, if these are both 90 degrees, then, and these are both the radius, so they're both the same length, then this looks kind of like a kite, right? Let's go back to the Google Doc. So a tangent to a circle is perpendicular to the radius drawn to the point of tangency. Okay, so I shared this doc with you too. You don't have to fill anything in, it's just if you want to get this into your notes. Second conjecture, the tangent segments to a circle from a point outside the circle are, so we're talking about the tangent segments. So that means from, let's go ahead and measure the segments I'm talking about. The tangent segments would be DE and EB. So notice those are the same, which is why this is a kite, because these two segments are equal. And then we also have the radii, or radii. Those of course are the same length. All the radiuses are the same length. So tangent segments to a circle from a point outside the circle are congruent. Gonna fill that one in. And then conjecture 3, the measure of an angle formed by intersecting tangents. So that would be this angle right here. So those are the intersecting tangents, that's where they cross. So we're gonna measure angle DEB. Okay, and we see this is 45.1, and it probably doesn't seem that special right now, but remember these two angles are 90. So a kite, the sum of the interior angles should add up to 360 because it has 4 sides. So we do 360 minus 90, that leaves 180. So there's only 180 left, and then we can subtract the 45.1, and that should be the measure of this angle. So if you have this exact figure with intersecting tangent lines, you're always going to get a kite. And so this angle here is always going to be supplementary with this angle. So it's kind of hard to say in words. The measure of an angle formed by intersecting tangent to a circle is, let's just say 180 minus the central angle, where this 134.9 is the central angle because it's created by the center of the circle. So yeah, 180 minus the central angle. That's how you find that. So I would give you problems kind of with this figure, and maybe you would know the central angle or you would know this angle, and you just have to do 180 minus to get the missing angle. So that is pretty much it for tangents to a circle. Now you can do the homework problems in the Google Doc that I shared and just type your answers directly into it. And then just so I know that you watched this video, go ahead and leave a comment on the Google Classroom assignment and just comment the word tangent. And then I'll know that you watched the video and I'll give you some extra credit. Bye.